Right, good morning. Welcome to my YouTube channel, Maths Aklu. Today, we want to continue with the nature of roots, but I have just one question that we want to look at. Given x squared plus m plus 3 bracket x plus m equal to minus 2. Show that the equation has real roots for all real values of m. Right, show that the equation has real roots for all real values of m. Right, now what we have to do, solution 1. What do we have to do? We want to show that it has real roots for all values of m. Right, for real roots, your discriminant must be greater or equal to 0. For real roots, your discriminant must be greater or equal to 0. So in this case, you have to rearrange that equation. So in the standard form. And the standard form, we know it's ax squared plus bx plus c. So let us rearrange it. X squared plus m plus 3 x plus m. Then take the 2 this side. So it becomes a plus 2. That one must be equal to 0. Right. Now we have written it in standard form. So that means your A is 1, your B is m plus 3, and your C is m plus 2. So for real roots, your discriminant must be greater or equal to 0. Let us see if this is going to be the result. Let's find our discriminant. Our discriminant is equal to b squared. B is m plus 3 minus 4. A is 1. It's 1. Then C is m plus 2. I normally don't want to continue writing that one because it is not going to make any changes there. So 4 times 1 times C. So now this is equal to, let us expand there. M squared plus 6m plus 9. That is the expansion of this part. Now go to that one. Minus 4m minus 8. This is our discriminant. Let us simplify. So m squared, 6m minus 4m is going to be 2m. Then 9 minus 8 is going to be plus 1. So if you check this one now, this one is a perfect square, which is equal to m plus 1 squared. So if you check m plus 1 squared, it's a perfect square. That means for every value of m that you put here, whether negative or what, this thing is going to remain positive. So this one is greater or equal to 0. In fact, it is greater than 0. It is greater than 0. So we have shown that for real values of m there, our solution is always going to be greater than 0. So the equation has real roots. So that is the first solution. All right. Now going to the second solution, it says find the values of m for which the equation has equal roots. Find the values of m for which the equation has equal roots. Yeah, let me. Here you can before you leave this one, you can just say therefore the equation, because we wanted to show that the equation has real roots. Therefore, the equation has real roots. You must round up. It's a concluding statement. for all real values of m. So that is our conclusion. Normally you get 1 mark for the conclusion. Right. So let us go to the second part. The second part, find the values of m for which the equation has equal roots. And from what we discussed some time back, we said our equation has equal roots if only the discriminant is equal to 0. Discriminant is equal to 0 for equal roots. So this one, you get a mark for showing this. Discriminant is equal to 0 for equal roots. So now this implies, from the equation, unfortunately I've erased it. Let me write it in the standard form again. X squared plus m plus 3 x plus m plus 2 equal to 0. That is your equation in the standard form. So already we got our discriminant earlier. Unfortunately, I removed it, but you were just supposed to pick it from where you have simplified it. So since I have removed it, let us simplify from the beginning. Our discriminant, okay, let me not write this, let me just say b squared, the bm plus 3, b squared minus 4ac. This one must be equal to 0 if the roots must be equal. So we have simplified this one as m squared plus 6m plus 9, then minus 4m minus 8. This must be equal to 0. Then m squared plus 2m plus 1 equal to 0. Right, so we have written it as a perfect square. We said m plus 1 squared must be equal to 0. So just pick the square roots on both sides. So m plus 1 equal to square roots on both sides. This side, the square root is m plus 1. That side is 0. Plus or minus 0, we cannot write plus or minus 0, just write 0. So your m is equal to minus 1. That is the solution for equal roots. M is equal to 1. So that is how you attack these questions. When they come in the examinations, you have to know your conditions, your condition for equal roots, your condition for real roots, and so on and so on. Right, so that is the end of the session today. Goodbye. Please subscribe to my YouTube channel. You will continue seeing a lot of new changes. Bye-bye.